Welcome back, welcome back. So, on Friday, we had a chance to take a look at part 1 of Chapter 1, Day 9, introducing experimental and theoretical probability. We looked at some basic demonstrations, some definitions. Well, today, we're going to be rocking part 2. And so if you flip on over to the back page, you will see that we got down to another example of how we can utilize probability here. So I'm not going to read this to you guys. I'll give you a second to read over. But you may want to highlight some pieces of info they give us here. Okay. And so obviously we've got what looks like 6 marbles here. 1 red, 3 green, 1 blue, and 1 yellow. We're picking 1 at random. Now, before we do that, what is the sample space? Well, how many marbles do we have? Well, the number of marbles in is 6. We got 6 marbles in this bag. That's our entire sample space. Whatever marble we pick out, it's got to be one of these 6. So you're going to see up here, X represents events. So in this case, X represents the colors. So fun fact, again, remember X represents events. So, speaking of which, I hope you guys had an eventful weekend. Shouts out to Somerset for taking care of business in football, and shouts out to the girls for taking care of business as well. So we know that we've got red, green, blue, and yellow, but what's going to be our probability out of 6 that we draw a red marble at random? Well, we got 1 out of 6. And so I'm going to pause and let you guys see if you can do green, blue, and yellow. And when you're ready, you can unpause the video. If I was smarter, I would have done these actually based off their color with the way I wrote them, but please forgive me there. Hindsight being what it is. So I'd say you guys probably knocked this out. We've got all of our probabilities here. And you know, you're my accelerated class. So I bet. Now, I don't want you to try 3 yet. Don't do that one yet. But I want you guys to see if you can tell me what you're thinking on these 3 right here. One of these I got a kick out of, but I'll let you figure out which one's I thought was kind of funny. So, we already knew number 1. Number 2, hopefully you were able to get this vocab right. If they ask us for the probability of not red, that means we're trying to find the complement of red. So in that case, we're talking 5 out of 6 of these marbles aren't red. Only 1 is. Now as for number 4, I'm deeply offended you even asked me, or I guess in this case, I asked me. Wow, I've got some issues. To find the probability of purple. Because last I checked, none of these colors are purple. And if they were, and these marbles were real, I wouldn't be able to tell because I'm pretty bad with the color purple. So that's a frowny face. Also a 0 out of 6. Or like me, that's just a straight up 0. So no chance there. On to the last page. That's right. Last page of day 9. This is the good thing about splitting this up into 2 parts. So in the past, I've had students write these out, this chart out. So you're welcome for having printed this out and saving you the time. And you're probably thinking, well, wait a minute, what is all this? Well, this is what would happen if you rolled 2 die. These are all the possible outcomes. So, for example, this row right over here is die 1, and this row up here is die 2. And then all of these rows in here are where these different rows collide. So if I roll a 1 on the first die and a roll on the second die, that gives me a combination of 1, 1. I roll a 3 on the first die and a 4 on the second die, that gives me 3, 4. You know, things like that. And so we've got, count them, 6 rows, 6 columns. How many different inputs, how many different events do we have here? You got it, 36. 6 times 6, baby. And so what we're going to do is, this is where things are going to get a little interesting. And the reason it's going to get interesting is because I completely forgot to take care of number 3. So that's interesting. How about the probability of red or blue for this marble problem? Now, guys, here's where we introduce a little bit of algebra. Red or blue, that word or means we're cool with getting either of them. And if we're cool with getting either of these, that's going to help our chances. In other words, we're going to add probabilities. If we're using the word or, we're cool with one thing or the other, that means we're going to add these probabilities. It's going to help our cause. So red is 1/6 plus blue is 1/6. That means if you're cool with getting either of these, that there's two marbles in there that we're fine with drawing. And 2/6 reduces down to 1/3. So that was interesting. A little interesting detour back. So that was fun. The first of many mistakes I'm sure I'll make. I hope not, but you know me. And if you don't know me, you will. So guys, now that we've kind of had a chance to look at individual probabilities and probabilities that involve the word or, we're going to see a mix of those here. So how about this one? What's the chances that we roll 2 die and our outcome adds up to be 3? Well, let's look. That adds up to be 3. That adds up to be 3. So 2 and 1, 1 and 2. And guys, I don't see any other combination that could do that. So we're talking just this combo and this combo. That is 2 out of 36. So our chances of getting a combination that add up to be 3 are not great. And since 2 and 36 are both even numbers, we know those can be reduced by 2. So this is really, gosh, what a great 8. 1 out of 18. That is an awful 8. Yeah, so not great chances. You got a 1 out of 18 chance. How about, on the flip side of things, if we were to roll 2 die, what are the chances that they don't add up to be 3? Well, we know that only 2 combinations add up to be 3. So this right here is the complement. We mentioned that word earlier. This is the complement of this problem. So if 2 out of 36 could be 3, subtract 36 by 2, that leaves you with 34 options that will not add up to be 3, which would reduce down to, divide them both by 2, 17 over 18. I'm going to do one more with you guys, and then I'm going to let you try your odds, see what your skills are right now. How about the probability that we roll a combo that adds up to be 4 or that adds up to be 7? Well, let's see. How many different options add up to be 4? Let's count it out. We got 2 and 2. We've got 1 and 3. We've got 3 and 1. And here's a little secret. It actually goes diagonally. If you're trying to see how many things add up to be 4, check it out. 3 and 1 is 4. 2 and 2 is 4. 1 and 3 is 4. See how that goes diagonally? So that is 3 out of 36 plus, how about 7? Down here, I see 6 and 1 is 7. 5 and 2 is 7. 4 and 3 is 7. 3 and 4 is 7. 2 and 5 is 7. And 1 and 6 is 7. That is 6 out of 36. And so when you add these together, using that word or, that means we're cool with either of these, we get 9 out of 36. And last time I checked, 9 goes into 9, and 9 most definitely goes into 36. We got a 1 in 4 chance, 25% chance of rolling either a 4 or a 7. That's a lot better odds than number 1, but not nearly as good of odds as number 2. So I'm going to let you guys see what you can do with 4, 5, and 6. Be extra careful on 5 and 6, guys. Probability of not rolling 7, 8, or 9, we're going to have to subtract all those from the 36 outcomes. And the probability of odd or 10, so we're going to have to add up, what you think about it. If there's 36 options, how many do you think are going to be odd? And the amount that add up to be 10. So go wild, guys. Go ahead and pause the video. Okay, so number 4, there are 3 options that add up to be 4, 5 that add up to be 8, and only 1, 6 and 6 that add up to be 12. You add those three together, you get 9 possible options out of 36 that meet this criteria, which is 1/4. Number 5 and number 6, you're going to see a little bit of a repeat here. 36, not 7, 8, or 9. Well, there's 6 options that could be 7, 5 options that could be 8, or 4 options that add up to be 9. We have to subtract those from 36, which leaves us with 21 out of 36 options that are not 7, 8, or 9, which is 7 out of 12. And then 18 out of 36 are going to be odd, right? Because either if you roll, it's either going to be odd or even. Turns out that half are going to be odd, 18, and half are going to be even, 18. So 18 options are odd, 18 events, plus there's only 3 ways to get 10, 6, 4, 5, 5, and 4, 6. So that adds up to be 21 out of 36 again, which means it reduces to 7 out of 12 again. So hopefully, guys, that's not too confusing, but if it is, please let me know. I don't care at all to meet with you over Google Meets, or if you're going to be in class, we can look over it and I can work some more out with you guys. As for the last thing today, I'm going to let you guys have some time to think about this as I do a better job of shading in what's actually supposed to be shaded. It's kind of hard to tell, isn't it? We got this piece, this piece, this piece, this piece. So be reading the directions, guys, as I'm filling these in. And this piece. All right. So I really like this section. I am not very good at throwing darts, but I'd say there's probably some people in this class that are sneaky good at it, even if they don't ever admit it. But what we're going to do here, guys, is we're going to say, hey, let's pretend I'm not throwing the dart, and somebody who actually is a pretty decent thrower is throwing the dart. Well, let's blindfold them just so they're on my level. If they throw this dart, hopefully it's going to land somewhere in the general direction of where we want it to. But let's say we're throwing at a target shaped like this. What are the odds that our dart hits this filled-in shaded area? Well, all 3 of these pieces are the same size. So if we're looking at only one of those pieces, that'd be a 1 out of 3 chance. How about this one? At first, this one looks maybe a little bit confusing, but think about it, guys. We have 4 squares here. Now, what do you notice about this square up here? How much of it is highlighted? That's right, half. Look down here. How much of this square is highlighted? That's right, a half. So, if we take a half of this one square and a half of this one square, that's going to add up to be 1 whole square that's shaded. Well, here's the thing. How many squares in total are there? 1, 2, 3, 4. So if this is 1 total square, it's going to be 1 out of 4. Half and a half make 1 whole square. Ooh, now this is where some math gets thrown in. We got 360 degrees in a circle. But how much of this is shaded in? Well, if this is 360 and we see a line right here cutting this in half, how much do we know is in this semicircle? Well, what's half of 360? That's right, this is 180. And if this is 180, guess what that means this whole piece is, both tiny pieces included. That's right, that means this is 180 too. Now, if you take 75 and put it over here, we're going to take, get my marker out, change it up. We're going to take 180, subtract 75, and how much is that going to put in this space right here? Well, that's going to be 105 degrees. 105 plus 75 makes 180, and 180, add that together, you get 360. And speaking of 360, that's what this ratio is going to be out of. we know our shaded section is 105 degrees out of the whole 360. Now that can simplify, and I would encourage you to do that maybe on a calculator, or just say, hey, look, they both end in 5 and 0. Let's divide by 5. And so you end up with 7 out of 24. That one was a little bit more complex than the first two. I thought we'd bring it back to something a little bit simpler. Check this one out, guys. Looks like we had 4 squares, but now they've been all split into halves. So each has 2 halves that make up the whole. Well, how many pieces does that mean we have in total here? 1, 2, 3, 4, 5, 6, 7, 8. Oh, and looks like 3 of those are shaded. So let's not overcomplicate this. If this is split into 8 pieces, we got 3 out of 8 that have been shaded. Now guys, no multiple choice today because we are going to be getting into our review tomorrow, and I want us to kind of be able to focus in on that. We got our test on Thursday. Look for directions on how we're going to do that this year. I have an assignment posted that is really simple. It's just going to have you upload a picture from your phone of 5 plus 5 into that assignment just to make sure you can take a picture because you're going to be doing that for your test. You also can plug your phone into your computer and upload it that way if you're having trouble, logging into Google Classroom through your phone. But guys, if you have any questions, you know how to reach me, and I'll be talking to you soon.